video. In this video, we're going to go through learning target 423, which is to interpret a line of best fit that's on a scatter plot and analyze the meaning. So scatter plots are used to relate sets of data. And so we have our independent variable on the x-axis and our dependent on the y. And then a scatter plot is just like essentially a bunch of dots. And you can see some examples here of different scatter plots. And so the correlation is essentially the relationship between those dots. The correlation is how strongly they are correlated with each other. So we have our graphs here, and you can see kind of the difference, and we can describe this correlation with a strength and then whether it is positive or negative. So I'll come back and talk about these R's mean in a second, but for now I just want to label each of these with the strength and then whether it's positive or negative. So it starts off positive because our lines are going up. Okay, so we can see these dots are going up. This one where the dots are all together, they're all in a perfectly straight line. This is a perfect positive. So the strength is perfect and it is positive. It's all of these dots are in a perfectly straight line. Now this one is close. The dots are all really close to the line, but not quite exactly perfect. So this we would say is a strong positive. So it's a strong correlation. It's a positive correlation. Next, we have dots that are kind of all over the place, but we do still see that we're going up. Like all of these dots are following a trend of up, and if we'd keep going, it'd probably look even clearer. This is called a weak positive. So it's still positive, we're still going up, but it's not super strong. They're all pretty far apart. Now this middle one is the turning point, so this is no correlation. So you can see like these dots are everywhere. We're not going up, we're not going down. They're just kind of scattered about. So this is no correlation. Now we start to see these are going down. Again, we're just going to go in we're going to use this exact same wording, but we are negative now because these dots are going down. So this one is a weak negative, a strong negative, and a perfect negative. Now these R's are the correlation coefficient. So I'm going to kind of write that right here. R is our correlation coefficient. And that's the number that represents the strength of the correlation. Our correlation coefficients are always between -1 and 1. And so now we can look back at these correlation coefficients and we can see what they actually mean. So a perfect correlation is a score of a 1. If it's perfect, it's a 1. If there's no correlation, it's a 0. Okay, so 0 is nothing. And again, a perfect correlation on the other side is a -1. And then anything between will tell you how strong or weak. So the closer to 1 you get, the stronger it is. The closer to 0, the weaker it is. So these are scatter plots and our correlation coefficients. The other thing we need to know is a line of best fit. And the line of best fit are like these lines in between the dots that estimate the graph. So line of best fit is the line that best represents the trend of the data. So if the data is going up, we're going to have a line that goes up. If it's going down, we're going to have a line that goes down. And our line of best fit is a linear function like normal. So it's y equals mx plus b. And then it'll be helpful to remind yourself that b is the y-intercept, which is always like a starting point. And m is our slope, which is our rate of change. So let's look at an example of what that's going to look like. If you need to pause it to finish those notes, please do so. I'm going to move the screen. So we're going to have something that looks like this with a graph. It's usually in some sort of a context. This one is talking about ice cream sales in Michigan. And this says the graph to the right describes the ice cream sales in Michigan. Describe the correlation between the temperature and sales. Give an estimate for the correlation coefficient. So when I say to describe, I want you to tell me the strength and direction. Strength and direction. So if you want to leave a little note here, this means strength and direction. So looking here, you kind of just ignore the line there for a second. Just looking at the dots, we want to see like how close are these dots to this line? Are they really close? Are they pretty spread out? Things like that. So I would say these dots are pretty close to that line. They're all pretty tight in there. So I'm going to say this is a strong correlation. And then I need to say if it's positive or negative. Since this is going up, it's a strong positive. It also wants me to estimate the correlation coefficient, so I want to give an actual number. And remember that a positive correlation will have a positive coefficient, and the stronger it is, the closer to 1 it is. 1 is perfect. This is not quite perfect, but it's pretty close. So I'm going to say like 0.9 would be my guess. 0.8 would also be a great guess, something close to this line. Then we could also ask something like this. So it says, given that the line of best fit is this, explain the meaning of slope and y-intercept. So our slope is our m, which is the number in front of x, is 18. And so we need to figure out what that means. I always make this into a fraction if it's not. And then I want to figure out what 18 represents and 1 represents. 18 is the sales, so I'm going to put a dollar sign there. And 1 is the temperature, so I'm going to put a degree symbol. So I'm going to say that every increase of 1 degree Celsius results in $18, I should say in an $18 increase in sales. You could also say like sales go up by $18 for every degree. Anything that explains that you know that we are going up by $18 every 1 degree. The y-intercept is 110. So our y-intercept on here is 110. And that means that our sales, so I'm going to say sales are $110 at, usually it's 0 degrees, but you can see like our y-axis actually starts at 10. So I'm going to say at 10 degrees Celsius. If you said 0, that would be fine. It's kind of unclear where this is supposed to go for our y-intercept, but I'm going to say 10. And lastly, would the value 20 degrees Celsius with the sales at 700 model the situation well? So you can also be able to find things on your graph. So if I go over to 20 degrees Celsius and I go up to 700 and I put a dot, this dot does not look like it belongs, right? It's pretty far away, so I'm going to say no, and I'm going to say the dot is very far from the line of best fit. I could also ask you things like if it's 14 degrees Celsius, how much do you expect the sales? And you go up to the line and you see like $250 would be a normal sales amount for that temperature. If I ask you like what would the sales be at 21 degrees, again, you can go up here, find that, and figure out how much money. So I want you to pause the video, go ahead and flip to the back and do the next 2 problems, unpause, and I'll show you the answers. And here we are for this first one. It's a strong negative correlation, somewhere around negative 0.8 would be good. The slope for every 150 meters, the elevation decreases, the temp goes down by 1 degrees. You could say that backwards as well, as long as you have those 2 numbers. Our y-intercept, the temperature is 22.5 at 0 meters of elevation, or at ground level would be a good way to say that. And then if we were going to predict the temperature at 3,000 meters, a good indication would be like 3. The next one, this is a strong positive. I would estimate it at like 0.7. For our slope, the mileage increases by 15,000 miles every year. The y-intercept, the mileage is 0 when it's brand new. That hopefully makes sense. The car's not been driven. And then if we had a car that's 20 years old, would it make sense for 295? 20 would be like somewhere over here. If we kind of scrolled up, like this looks like where the line would be. That looks like a normal amount for it to be 295,000. Also, you can plug that number into your formula. So if I plugged in 20 years here, it gives me 300,000. So 295 is a pretty normal estimate. All right, I hope that makes sense and that you like this learning target.